So what does a VPC consist of? What are the VPC elements? Well, for starters, it consists of subnets. When you create your virtual private cloud, you can create one or multiple subnets so that you can design your environment the way you want. Private subnets, public subnets, VPN subnets, you can design any way you want. Remember, a virtual private cloud is your isolated logical environment on the AWS infrastructure. It's very similar to what you have on premises. On premises, you probably have a physical data center, something that you walk into, you install your gear, your equipment, but then the network is logically created. It's created essentially in software. So what you have with a VPC is the equivalent of exactly what you have on premises, minus all of the physical elements like routers and switches. All of that with a VPC is done in software as opposed to having a physical data center that you can go into and install rack, stack, and cable. So you can do subnets. You can do route tables. Again, very similar to what you have on premises. You create route tables, you assign route tables to subnets so that you know how traffic is routing, you can control how traffic is routing. Internet gateways. Internet gateway can be created so that you can give access to the internet to instances and services that you put in your virtual private cloud. Elastic IP addresses. Elastic IP addresses are in essence public IP addresses that you can associate with instances so that they can be accessible from the internet, or sometimes you can assign elastic IP addresses to services as well. Now, the advantage of an elastic IP address is, first of all, you're drawing from a pool of IP addresses that AWS makes available to you, but once you release that IP address, it goes back into that pool. So that pool is not dedicated to you. You or someone else can grab that IP address. But the advantage of an elastic IP address is that you can easily associate that IP address with other instances or services. So it's mobile, so to speak. Endpoints. Endpoints are great because there are some AWS services that are only accessible via the internet. So for example, if you had instances in a private subnet and they needed access to S3, they would have to go all the way out to the internet and then come back to S3. This created some challenges for customers. So what AWS does is you can create an endpoint so that you're directing the traffic to S3 to stay local. It doesn't go out to the internet anymore. So this is what an endpoint is used for, and we'll demonstrate that a little bit later. NAT gateways. So a NAT gateway is the equivalent of what you would otherwise have to do with a NAT instance, which is to install a server and make it into a NAT instance. A NAT gateway is a service that AWS offers that is managed completely by AWS. And then we have peering connections. Now, what a peering connection is the ability for you to have a peering connection between two or more VPCs. So if you are a solution provider, maybe you're a consultant, and you have several customers that are using AWS, and you have your own VPC, you can create a peering connection to your different customers and be able to access resources on their VPC. From a security perspective, you have network access control lists, or NACLs, very similar to what you would have on premises, what you would find on premises. Security groups is another security mechanism where a security group can be applied to any particular object within AWS. And then you have VPN. Now, VPN comes in different shapes and flavors. You can have site-to-site VPN, which is going over the internet. You can have a dedicated private connection in the form of Direct Connect. We talked about the ability to architect the network the way you want it. So what did I mean by that? So let's draw this out. So let's assume this is your region, and within your region you have several availability zones. Now remember, each AWS region has at least 2 availability zones, sometimes more. When you're creating your VPC is region-wide, which means you can take advantage of all the availability zones that are in it. Now within each availability zone, you can create subnets. So for example, you'll have subnet 1, subnet 2, subnet 3. Maybe subnet 1 and 2 are in availability zone 1, whereas subnet 3 and 4 are in availability zone 2, etc., etc. Now the way this really works is what Amazon is doing behind the scenes is they're putting a router. Now this router allows all of these subnets within the region across the availability zones that are in the same region to be interconnected to one another. So without needing to do anything else, those are already interconnected. You will have access to those via routing. When you deploy resources, they'll be able to connect to the other subnets within the region. Now, the way to control who's getting access to what is going to be through security groups and network access control lists, which we will discuss later. Now, let me show you what it would look like if you were to put, kind of a subnet around it, because this is the exercise that we're going to be doing once we get into the demonstration portion of this lesson. So it would look something like this. So at the top of the region, your VPC master address would be a 192.168.0.0/16. Now a /16 obviously equates to a subnet mask of what? Anyone? 255.255.0.0. Now, within that master subnet, within that bubble that you just created, you can begin to carve up your individual subnets. And in this case, you'll have subnet 1 with a 192.168.1.0/24. And then you'll do the same thing for 2, 3, and 4, etc. So you're able to architect your network, you're able to architect your subnets based on that master subnet that you've just created initially.